these are some textbook exercises from section 2.3, page 109. And the first thing we're going to do is determine if this is a linear function. So we're looking at a table of values. When you're really looking at table values, you're looking at four ordered pairs here: 2, 9, 5, 17, 8, 25, and 11, 33. One of the quick ways to check if it's a linear function is to look for that constant ratio. So I'm going to look and see that I have an increase of 3 each time for the x value. And then for the y value, same as f of x, we see that we have an increase. And we're looking to see, first of all, if it's a steady increase, and second, we're looking at the rate. So I'm going up by 8 here, and another 8, and this also goes up by 8. So with that constant change, I can see that it is linear, but what you're really looking for is that ratio, the change in y, so the change in y over the change in x. And in our case, that is a constant change of 8/3, or a rate of change. So this is linear, and the constant rate is 8/3. Okay, I have some graphs here. So the next one asks us to graph based on given the slope and an ordered pair. So slope is 5/2. We know that as rise over run. And we have this ordered pair, x and y. So this is going to be my anchor point. This is where I'm going to start. So I'm going to do number 5 right here. And so when I go to do this, I plot my point at 0, 2. So this happens to be the y-intercept. So put a point there at 0, 2. And then I'm going to do my slope. I'm going to rise 5, 1, 2, 3, 4, 5, and run 1, 2. So it's a positive rise and a positive run. I can also go down 1, 2, 3, 4, 5, and I would go left 2. I have a positive slope, so my line should be increasing as I go from left to right. So it's a little bit steeper, but it's a positive slope. Now, the next one we are graphing using x and y intercepts. So it's really important that we find the intercepts. So we want the x-intercept and we want the y-intercept. So you want to follow these directions here for full credit. So when I go to do this, and I'm talking about x and y intercepts, there's two facts that I know about the x-intercept. Fact 1 is the x-intercept is on the x-axis. The second fact tells me, since it's on the x-axis, that the y value is always 0. So I'm going to take that y value and plug it in, and so I have 5x plus 6 times that 0 equals 30. And that's going to zero that out and leave me 5x equals 30. Divide both sides by 5, so x is 6. Now, the way I would like to look at this is if I'm going to talk about the x-intercept and you tell me x is 6, I'm looking for the x-intercept to be listed as an ordered pair. So that's part of your answer. So we're going to plot that point at 6, 0. There you go. Now we also need to find the y-intercept. So the two facts I know about the y-intercept is that it's on the y-axis, all right? And if it's on the y-axis, the x value is 0. It's not to the left or the right. So the y value is what we're looking for when x is 0. So if I know that the x is 0, I'm going to plug that in so it cancels out that term, and I can solve for y. So divide both sides by 5, and I get y, oops, let me go ahead, 6y is equal to 30, sorry, and I'll go ahead and divide by 6. So y is 5. I jumped a little ahead there. All right, so basically I rewrote the problem here, and I've got my ordered pair. So a separate idea, and I plot that point at 0, 5. And that's all it takes are 2 points to create a line, so I can go ahead and connect those to make my line. Now this line has a negative slope, and that makes sense. If I would solve this for y, I would subtract the 5, and that would give me that negative slope, so my line is dropping from left to right. Okay, number 13, this is how we normally graph. We have this equation again in standard form, ax plus by equals c, much like this one was in standard form. Here we found the x and y intercepts. Here I want to do y equals mx plus b. So I want to solve for y. That means I'm going to take this whole 5x and subtract it. So I get y equals, I'm going to write it as negative 5x plus 4. You can have 4 minus 5x. what you need to remember is that your slope is -5/1. Your slope is always paired with x, and your constant is b, that y-intercept. So when I go to plot this, I put my point at 4, and that y-intercept is truly 0, 4. It's on the y-axis, so I start there. That's like my anchor. And then I'm going to go down 5 and then +1. So down 5, +1. Again, I have a negative slope. So down 5, +1, and then I should be dropping. So there is my slope. And again, it's dropping from left to right because I have a negative line. Okay, we have, is this vertical or horizontal? And then graph it. Well, I see that it says x equals, so I know that this is going to be a vertical line. Let's take this a little bit further. Not only is it a vertical line, the slope is undefined. And so that might help me to think about this. All of our other equations are y equals mx plus b. Okay, so you can see I got this one, y equals mx plus b. It has a negative slope, so it drops. I could solve another one. If it was a positive slope, y equals a positive, it would go up. So positive and negative slopes fit this. And if I even have a 0 slope, that'd be just y equals b. This is when I get a horizontal line. Okay, so if I have a 0 slope, I have a horizontal line. And so what I want to point out is a positive slope and negative slope, I still have y equals. A 0 slope, I still have y equals, and I have a horizontal line. But the minute I see x equals, I know something is different. Doesn't fit the rules of y equals, and so my slope is considered undefined. This cuts through the x-axis at 7, just like that. So there is my vertical line. My slope is undefined because if I start here, I rise 1 and I run 0. And I can't divide by 0, that is undefined. All right, next and last problem that I'm going to review from the homework is a word problem. So I went ahead and I just wrote it down pretty quickly. If we're looking at this, it says we have a register that starts with $150. Okay, that makes sense because you need some change to give back to customers in your register. And over the course of the day, 8 hours later, the register now has $738. So we want to find the average sold or average dollar amount per hour and then graph it. So there might be some hours that are slower than others, but we're going to take this up and down however it worked and sort of straighten it out to level it out to say this is the average hourly money made by the store. So what I need you to think about is thinking about this as an ordered pair. The hours are like my x, and the money in the register is like my y value. So when I start, I have 0 hours, but we have $150 in the register. And that's when we start. And at the end of the day, or the end of this register shift, we have 8 hours, and we have $738 in there. So if you think about this in the form of the change in y over the change in x, that would give us our average amount of money per hour, how much was sold per hour. So we would look for the change in y over the change in x. So the change in y would be the 738 minus 150. Basically, you're taking off the money you started with, so how much actually came into the register. The change in y was 8 hours minus 0. So if we do the math here, we end up with $588 over 8 hours. So that's why it's a rate of change, $588 for every 8 hours. We can reduce that or divide it out, and we get $73.50, and that'd be dollars for every 1 hour. Now, that's it. That's my rate of change, $73.50 for every 1 hour. That's our average, where we balance out the highs and lows. So that's good. Now, it asks us to graph that. Well, guys, to graph this slope of 73.5 would be really hard, especially if I can't count by ones or halves here. And I can't count by ones and halves. So what I'm actually going to do is I'm going to use these ordered pairs to help guide my graph. Now, I'm going to have to slide my graph down. So let me transfer that. 0, 150. And 8, 738. The other thing is I want to label my x and y. So down here would be my time, and that's measured in hours. So what do you have? What's it measured in? And over here would be the cash in the register. So cash in register. All right, so the hours I can count by ones or every half hour. It's up to you. We only have to go to 8. So maybe I go 1, 2, 3, 4, 5. You always need an even interval. All right, so I got to 8. I also could count by ones. I counted by halves. Now I'm going to have to get to 738 if I want to use this ordered pair. So if I count by 50s, that'd be 1. I think I can count by 50. So I'm going to show every 100, but each block stands for 50. So 200, 300, 400, 500, 600, 700, 800. And that's good. Now, what I want you to remember, cash and register is in dollars. Okay. What I want you to remember is if I'm going to count by 50s, I have to have 50, then 100, 50, and then 200. And a lot of people skip that first block. All right, my first ordered pair is 0, 1, 50. That's actually the y-intercept. So I'm going to plot that y-intercept at 0, 1, 50. Now, knowing that my slope is 73.50 every hour, I would go up 73.50 and over 1 hour. It should be about here. If I'm estimating there's 50, there's another, change to get to 73.50, and then over 1 hour. I'm thinking my point should be there. But because I'm estimating that slope, I'm going to go ahead and plot that point at 8, 738. So I go up to 8, and then 738 would be just down from 750. And that would be a pretty good estimate. And I'm going to start here, and there goes my line. Okay, now if this was the trend that was continuing, then my line would keep extending, and I could say, well, if we planned on this happening, I could tell you what would happen in 10 hours. I could tell you about how much money there might be at 4 hours, and I could use this line to predict. So important things here is that we could look at these as ordered pairs to find that rate of change. And when we go to graph, we have even intervals, and we label our axes. And the best thing to do before you start labeling is to look at your numbers.